Well, now, I probably need hours to spend practicing this, but let's see if I can do this without dropping everything on the floor. Okay, I've got two masses, this one clearly bigger than this one, and I'm going to hold this about the center. If I do, and I leave go of this hand and let the thing rotate freely about the center point, the point halfway between the masses, we see that it's going to go down this way. Okay, if I just let this go, it rotates down. Of course, I stop it because I don't want to keep picking these things up off the floor. So, if this thing rotates a little bit this way, the net potential energy of this system decreases. If it rotates a little bit this way, well, it's not going to do that spontaneously. I'm going to have to exert an extra force, but the net potential energy is again going to change. And I'm going to have to do work on it. If I release it from here, gravity will do work on it and it'll rotate that way. Okay? Now, if I hold it too close to this mass and release it, well, it's going to rotate this way. Okay? And you're going to have a potential energy change. And if I want to rotate it this way, I've got to do work, okay, in order to accomplish that potential energy change. Now, if I get it at just the right point, just about lost it there. Okay, it'll balance. Okay, I can get my fingers off of it. Okay, and of course I would have a fulcrum down here to do this just right. And I see that I don't really have to do any work to move it. Just a very little bit of work to get it moving, and then it moves freely. Okay, so this is the balancing point. It's a point at which the potential energy doesn't change with a small rotation. Can I illustrate that with a picture here? Okay, mass little m, mass big M, which is bigger than little m. Try to balance it at the midpoint. It's not going to work because a small rotation is going to entail a change in potential energy. Okay, small rotation, net potential energy changes. It doesn't balance. Okay, if you get too close to the big mass, then if you rotate it, well, up here you rotated it and both masses moved in the same distance, but in opposite directions. One mass being greater than the other, gravity was going to do more work on the bigger mass. Okay, here you're too close to this mass, so if you rotate it a little bit, this mass doesn't move much at all. This mass moves quite a bit. So even though this mass is less than this one, it moves a lot further, and you have to do net work. Okay, gravity will do net work on it. Gravity will do more work on this one than on this one if you try to rotate it this way. Of course, the work will be in opposite directions, right? So the net potential energy change could be positive, could be negative, could be zero for a given rotation. So if I want to rotate it in this direction, in this case, potential energy change, rotating it in this direction would be negative, rotating clockwise, because the big mass would go the same distance as a little mass, but gravity would do more work on the big mass, and that would be negative work, positive work, and would do less work on the little mass, but that would be a positive work. Okay, well, so when everything balances, what happens, of course, is that you want to be closer to the big mass than to the little one, because in order for the work done by gravity to be equal and opposite, the little mass is going to have to move further than the big mass, right? Now they move in opposite directions vertically. Okay, one moves up, one moves down. But if you're at just the right point, a little bit of rotation will result in zero net work being done. Okay, a negative work on one side balanced by the positive work done on the other. So at just the right position, you have no net potential energy change with a small rotation, and that's your balancing point. Or, didn't use this term in class, so I hope everybody's watching. The center of mass. So the center of mass is a point at which you can balance the system in such a way that there's no net potential energy change due to a small rotation.